Hey everyone, welcome back for another episode of the 5G Guys. I'm Wayne Smith, and I'm joined as always, by my co-host Dan McBall.
Hey everyone, great to have you back. I'm excited for another episode. Today we have a special guest from a startup company called EdgeQ. His name is Paul Steger. He currently serves as the Senior Director of Engineering at EdgeQ, where he's applying his expertise in radio frequency systems to help them develop a new generation of chipsets that'll be really disruptive to how wireless networks as we know today are deployed. And we'll get into some of that detail a bit later with Paul in the conversation. But just for some background, prior to EdgeQ, Paul was working with Cisco, and he was working as director of radio frequency engineering and digital signal processing. I think he spent somewhere of 26 years, you said, Paul, at Cisco before you moved to EdgeQ, so quite the veteran over there. And he led the development of the industry's first Wi-Fi beamforming solution, as well as a bunch of other Wi-Fi technologies that make Wi-Fi what it is today. Prior to Cisco, he worked for Aeronet Wireless and Grayson Electronics. He's done speaking events with Cisco Live, very involved with their Pioneer Awards. So, Paul, great to have you, and thanks for coming to join on, and I can't wait to get into stuff with you.
Hey, thanks, Dan. Wayne, really excited to be here. I've been listening to your podcast, and I'm learning some stuff. So you can be in this industry a long time and still not be up to speed on everything, I'll tell you.
Yeah, whenever we always have a saying, Wayne and I, if somebody says they're an expert, then we know they're not.
Spot on.
Yeah. So listen, so you've worked in your career not just on Wi-Fi, as I highlighted at Cisco, but also on cellular systems, going back to some of your earlier career stuff and what you're doing with EdgeQ now. So I think this is a good opportunity for us because most of our guests come from one facet of wireless to the other. You've got a foot in both sides. So I'd really love to take the opportunity to kind of hear from you and your background on cellular and Wi-Fi and some other wireless technology you may have worked on. Kind of what's your observations of the history of where they all came from and how they might be converging in our world today. So maybe just give us a little of that background.
Yeah. So I guess just a little bit more background on me. I was really lucky to get an intern job with Ericsson GE in the 90s. And in that building was a little bit of everything when it came to wireless. I was working on land mobile radio, but you could walk down the hall and guys are building cell phones and, those bag phones and things. And there's base station work being done. So it was quite a mix. And then with Grayson working on cellular microcells and things, and then getting over to Aeronet when it was a startup and when Wi-Fi was just coming together, just taking off. So very early having a chance to see a little bit of everything and see how it evolves, while I was at Cisco. And, the thing about getting down to the fundamentals of what, technology brings, I think it kind of starts with what problem you're trying to solve and what constraints are you working with. And when I was getting to see cellular take off, it was the problem was voice and coverage, coverage over square miles. And then with Wi-Fi, totally different, data communications and, how do we cover just this little building or even just a portion of the building, maybe where manufacturing is happening and you want some data or whatever. So really different problems. And the constraint was very different too, on the cellular side, licensed spectrum and all that you can do with that in terms of control. Base station is really in control of what's happening over the air. And then, looking at Wi-Fi and unlicensed spectrum, you got to do something really different to make sure that, the airtime is accessed fairly with all devices and it's open. And networks that don't even cooperate with each other are able to do what they need to do and send the data they need to send. So really different problem, really different constraints, and it results in really different solutions that I think even if they grow closer together over time about the problem that they're solving, it's really a story about the spectrum and the licensed versus unlicensed and how close they can really get. I guess we want to, make an analogy, I know you guys are kind of big on analogies, right? With the cellular system, it's really coordinated, it's really synchronized, and when you get a lot of users and scale, it's that situation where you're maybe leaving the stadium after a ball game or something, a lot of traffic. You're really happy to see that police officer directing traffic because he's going to get you out of there in a really efficient way, and that's basically what the base station is doing. And it leads to something that's deterministic and reliable, and everything on the network knows exactly what it's supposed to do and when it's supposed to do it. With Wi-Fi, you have to let the individual components make some choices and about what do they hear on the air, and can they jump on? And the thing is they actually allow for or expect a number of collisions. Not exactly what you want if you're leaving the stadium, but after a game, but so that's not going to be fundamentally allow for reliable, deterministic. It recovers from that. But if you're going to tell somebody when you're going to get home, you're not going to have that deterministic type of behavior. But it works for unlicensed, and the scale it brings, it just has some inherent inefficiencies that fundamentally are the difference between licensed and unlicensed spectrum, right?
Hey, real quick, a quick word of thanks to today's sponsor, Vertex Innovations, before we get started. For over 17 years, Vertex has been building the nation's wireless and broadband networks. Providing project management, network engineering, and construction oversight are just some of the ways Vertex helps their clients. So if you're looking for more of a partner to help you with your wireless network designs, construction, implementation, or operations, reach out to Vertex. You can find them at vertex-us.com. That's VERTEX-US.com. I think another big difference that I've always thought about is mobility versus fixed.
Yeah.
Right. You really, cellular is built and designed to be a mobile network where the users are moving all the time. Wi-Fi, not so much, at least not originally, right?
Yep, exactly.
Yeah, one thing that comes to mind for me that was a great analogy, by the way, leaving a stadium. One of them is reliable and determined. That I think, from the early days, I don't know that a user would have thought about the reliability of both. But as things progress in technology, I think the expectation is both are equal. You don't look, I know that dealing with youth or younger generation, as they look at Wi-Fi, they look to have the same performance and the direction that cellular. So do you see that experience even getting closer together with the same expectations on the user's end?
Oh, well, not only the same expectations on the user's end, but when I listen to my son, complain at home, like the Wi-Fi is terrible, I'm like, well, that might be the cable, it might be something else, but to him, it's just the Wi-Fi. And even on a road trip, he's downloading a video. Hey man, what's up with the Wi-Fi? I'm like, dude, that's not even Wi-Fi. but
yeah.
the it's not only the expectation of the connectivity and the experience, but also just blending all of that connectivity, into the same thought, about it. But that's definitely the story of how we think about those two systems, but it's also the story about, the journey that they've been on, right? Definitely cellular started as a voice, connectivity problem. And what's on the either side of the link are, two humans, two people trying to have a conversation. And that's, what it's all about. It didn't take long to where data moved into that as well, right? And we see that with, Wi-Fi. Wi-Fi starts with data. It picks up voice, and it's also increasing in its complexity in the way it's managing the network and the users in order to scale into an enterprise environment or that stadium or healthcare, where reliability, quality of service, is the expectation. So, we see not only the technologies changing along the way, but how we view them, and they've always been coming together, not further apart.
Yeah, I think there's an interesting use case out there that really tells the story of them coming together and really just being two different tools in a holistic communications toolbox, right? This story I heard one time, it was actually about 5 years ago, and it was in Japan. And basically the cellular operator over there, I think in this case it was NTT, but I'm not positive, but they had, lots of cellular network all over the area. And then what they did is they also deployed Wi-Fi network that was working in tangent with the cellular network. And, they were making sure that the devices that the users had could do a good job of smartly moving from the cellular network to the Wi-Fi network and back. Very different than what we have, at least in my experience here in the States today, where if your phone's on Wi-Fi, it's not smart enough to say, well, yeah, maybe I've got enough bars, but I don't have good internet connectivity, like what your son's example was. Not smart enough to tell the phone, hey, get off of Wi-Fi now and get back to cellular. But in the case of this use case, they had done some work on doing that. And what it afforded them to do is to use Wi-Fi to help offload capacity off of the cellular network in, for example, a concert venue. And they literally they called them Wi-Fi ninjas. There were people they hired that would carry a backpack with a battery, an access point, and then they would use 4G backhaul to the internet. And they would just tell them, hey, go stand by the stage where it's a hot spot. We're having capacity problems. And they'd move over there, and users would shift over to Wi-Fi, and it would take the burden off the cellular network. So it was blown away when I heard that use case. Are you starting to see, or do you envision similar use cases like that here in the US?
Well, definitely. I did a number of deployments when I was at Cisco, and one of them was Bottle Rock. And that's, again, a large scale problem for Wi-Fi. Cellular's in the mix, but the Wi-Fi was carrying a lot of the data load. The traditional view of Wi-Fi being sort of a easy, simple to install antennas and access points and everything are not very complex. But in a situation like that, it is pretty complex, but it can do the job. There's 5G coming in there, and it's going to be very similar, getting closer to the user for that capacity, right? Because that's where Wi-Fi is providing the capacity, cellular is providing the wider coverage, but then we're going to see those things in the future kind of blending together where they're both getting closer to the end user and providing that capacity. So just another tool in the toolbox, like you said.
So in addition to those two tools in the toolbox, we've done a lot of episodes around some other technology that's really been coming out the last couple of years. Some of our earlier episodes, for example, we talked about artificial intelligence. We've talked about how processor capacity and computing power has just gone through the roof, and that we now have the ability to push that computing power closer to the users, which is called edge processing, right? Can you talk a little bit about your observations on some of those other technologies and how those are playing into this convergence of Wi-Fi and cellular?
Yeah, this is what EdgeQ is all about, right? We talked about voice. There's data. The third thing that comes into play there is compute, and bringing that closer to where compute has to act on something, and it has to do it for a purpose. The connectivity is moving the data that the compute needs to act on. The users, are at the edge, whether that's, people or machines or whatever, sensors that want, not only the data that's getting moved around, but the results from the computation, the artificial intelligence, right? If we take it back, to that example with cellular and voice, the two things on the end of either end of that link were people having a conversation, processing the data, thinking about what was being said, responding to it. And when we go into the future, it's like, well, the two things on either end of that, could be literally machines thinking about the data, artificial intelligence acting on the data. without anybody any people in the loop really. And so, where does that compute power reside, and how efficient can we make it, and how much can we blend it and work seamlessly with the connectivity technology that's there? And that's what EdgeQ does.
Yeah, I mean, Dan, if you can jump in, but I did have it's an interesting question when you bring up the word compute, and make sure I understand, and for our listeners. So it makes sense with the voice and the data. The compute, when you use the term compute, are you saying that in real time, closer to the user, that computational type algorithms will be used to give an immediate result to that end user without going somewhere else? Is that what you mean by that? Compute, or is it mean something else to you?
It definitely means that, and I guess it means a little bit more too, because when we think about the processing that's done for the connectivity, for the signal processing, at some level that starts to look a lot like the same processing that happens in for AI and inference, and so the same hardware starts to be reusable, and so you could do more with the same piece of silicon, as well as having that as close to the user, as close to the data as it can be, without burdening the rest of the network or adding latency to the decision making that's happened in the AI.
Yeah, I mean, that's really helpful. Would you call it translytic data, or the ability to have on-demand real-time processing and reporting of new metrics not previously available at the edge?
Yeah, because data has a shelf life, and also, not only does it have a shelf life, the value of working on the data is related to the expense of moving the data. And if you do that closer to the edge, you get your really low latency decision making and actions, as well as you're really adding value in terms of dollars and cents to the usefulness of it.
Yeah, so I guess in that sense, one of the big claims for 5G is much better latency. And for listeners that don't know what latency means, it's the analogy we used in one of our Cellular 101 episodes clear back at the beginning last year was it's like the responsiveness of the gas pedal on your car, right? Low latency, older generation cellular, you push the gas and the car kind of responds a little slower because it's an old Chrysler Plymouth, whatever, and you don't really get the feedback from the engine to go do what you're wanting to do. With 5G and AI and edge computing, that really affords that responsiveness to be much greater. So when I'm, doing whatever I'm doing that requires compute power, the analogy would be I'm now driving a McLaren and I just barely touch the gas and I'm getting that response right away. And I'm going 0 to 60 in like 2 seconds, right? That's really, it's not just speed and bandwidth, but it's how quickly the system can respond to what you need or what a device needs out of the network. And that, I think that is probably one of the biggest advantages of 5G and all the other things like compute power and edge computing we're wrapping around it. Does that sound right?
Yeah, that sounds right. And I would add too, it's also sort of like you have the data coming back from your environment. You see some car pull out in front of you. If that loop to your foot isn't closed fast enough for you to put the brake on, that latency is really important. You want to get the information to the compute power to what it has to do, stop the car, right. And it's important.
Yeah, and like in traditional Wi-Fi or traditional cellular from generations past, the measurement of latency that we would look at is in hundreds of milliseconds, might be 100 milliseconds, 200 milliseconds before you get that responsiveness out of the system. Sounds like it's fast, but it's actually really slow, right? Because with 5G now, what are we talking about? Single digits to 10 milliseconds, 10 to 20 times faster than it used to be.
Right. And and what 5G does, it just continues to to build on the inherent strengths of or advantages of licensed spectrum and in that, base station control of what's happening and being able to allocate the resources and the time and the schedules, before you have to actually do something. So everything in the system knows when it can move data, and it has the really fast mechanisms to say, I have to move some data really fast and get it done. So, and that's inherent to the licensed spectrum. So it is very much a spectrum story in that regard.
Yeah, I think one good point you brought up, and I haven't heard it put that way, is that data does have a shelf life. And the value in the data is getting to use it rapidly to make decisions for an outcome. And so that's really key distinction for me. I do definitely appreciate and can relate to what that means.
So Paul, tell us a little bit more about EdgeQ and what is EdgeQ's role in all of this?
Well, EdgeQ is a 5G connectivity company. We're building the chips that are going to make 5G in the enterprise space affordable and at a scale that is meaningful, right? And also a compute company because we acknowledge the very early, the power of that relationship between what we have to do for connectivity and what's required for artificial intelligence, machine learning to get done. And also the relationship between those things, voice data, now compute, and taking the action that's needed. So that's what we are. Hopefully we're going to enable, the 5G systems to get closer to the user in more places for that capacity and the edge computing power.
So is it similar to, say, like an Intel or a Qualcomm companies people might recognize that are doing chipsets for technology? Is it a similar story, but you guys are doing something more disruptive than they are that's going to change the way these networks are designed and built? And if so, what is the key disruptor that you guys are using that's going to really position that way?
Right. So yeah, it is similar that those companies are developing, silicon for 5G, but I think the disruptive aspect is the degree to which we've made the silicon software definable and versatile, and that we can take the compute that's in there and repurpose it or share it and do that very seamlessly. So I think the difference is going to be in how we manage that.
So we would see or hear of EdgeQ silicon showing up inside of a subscriber device like a phone, or showing up inside of an access point on the network side. Is that effectively the consumer may not even know who EdgeQ is or care?
Right. The consumer may not even know who EdgeQ is or care. I know my son won't when he's connecting, but yeah, we're gonna show up in small cell. We're gonna show up in Open RAN architectures where the same piece of silicon is used in a small cell application as well as a DU distributed unit in an Open RAN network. So it's going to be a very flexible piece of silicon that they can do a lot in the 5G network and be software defined for computation as well as connectivity.
So pretty amazing to demystify it. It is hard for a user to understand, but the chips are there in order to make connectivity easier in those applications. So like maybe I think I read a little bit about you guys on the fixed wireless 5G. Where would your chip sit in that environment? Is it at the end user antenna or is it somewhere else?
Well, the initial, I guess, product launch is mostly centered around the small cell space and the Open RAN DU, so on the infrastructure side. But that's another fact of it as well. It's the silicon's been built in a way that's very flexible and software defined, and it can sit on the user side as a UE device as well. It just requires that software stack to be on the same piece of silicon.
Mm-hmm. Yeah, and so for users that may not be connecting the dots entirely, what Paul's company EdgeQ is doing is when he talks about Open RAN stands for RAN is Radio Access Network. So Open RAN is a concept where instead of historically in our industry, you'd have companies like Motorola, Alcatel-Lucent, Nokia, Ericsson. These companies are basically providing chipsets and equipment that runs off those chipsets in a very specific, tailored way that they do a specific frequency band or bands, specific type of technology. And then as a network deployment company, you have to basically buy that equipment from them and pay them service fees or royalties for that to work. But then if 2 years down the road, I now want to do something completely different, say in the Wi-Fi space or whatever, I have to go buy a different product from them. So Open RAN is a concept where the end user that's deploying the network or using that chipset can effectively program and change what that chip's function is supposed to be, what frequency band it works at, whatever the case might be. Is that the best way to describe Open RAN to the audience?
Yeah, and beyond that, it's having different. There's the 5G core, and then there's the RAN equipment, and not only is there the RAN equipment, there's different ways to make the RAN, whether it's a small cell or these radio heads and DUs, things that sit further away in a central location, making it open, disaggregate networks so that other vendors can easily plug into those systems is so there's a lot less lock-in to one vendor base for service providers or whomever wants to deploy networks.
Got it. So tell us a little bit about unique use cases you guys are running into with the technology you're developing. There's a lot of, we've told our audience in the past that the most impactful changes that 5G is going to have may not be visible to the end consumer, right? It might be in the background. It might be making changes in the way the world around us works. Can you give us some use cases that speak to that?
Well, yeah. I mean, I've started working with some companies that literally want to send this stuff out of the world, right, into satellites. So that's the NTN, non-terrestrial networks, and so now we're taking the same 5G technology. There are some changes for the NTN in the next releases of the standard, but essentially that same silicon can now do those non-terrestrial links to satellites and airplanes and all these devices that we didn't think were part of this normal network that we operate in with our phones every day. So that's a pretty amazing notion that we're just going to take this same piece of silicon, same basic technology, and take it into space. So I'm excited about that. The other things are areas where some of the limitations around latency and reliability that other wireless systems have had. There's going to be a lot more factory automation. These aren't terribly new concepts, I think, but there are still problems yet to be solved, or at least deployed to on a mass scale for the factory automation and low latency, high reliability situation. So, definitely seeing those things emerge, and then just the pure capacity play, right, where the cellular networks definitely have to get closer to the user in order to get the highest data rates and highest capacity. A lot where we think about Wi-Fi access points just being everywhere, but they're not a mile and a half away. They're right there in the Starbucks or your home or at the office, right? So I think that's definitely an area where we're going to see 5G come into as well.
So that demands changes with regard to scale, right, and size. and price, right? So it feels like an open RAN solution is a way to drive that price point down and allow it to be deployed at the same sort of scale that we saw with Wi-Fi, for example. Whereas Wi-Fi, everywhere you go, you pull up your phone and you see 50 hotspots show up, right?
Yeah, I think that's going to be the future. I definitely don't see one crowding out the other, like 5G crowding out Wi-Fi or that. I think they're going to come into the same spaces, but once you get down to the fundamentals, they might even start to address the same problem, but they're never going to be operating under the same constraints, and that comes back to that spectrum question again. I think what's going to be really interesting and what was so amazing about Wi-Fi was the Wi-Fi came in, and with the unlicensed spectrum, it really brought the wireless technology very close to the user, and the creativity of the customer in the industry just took off. And there's explosion of use cases, and now it's everywhere. I think when 5G starts to enter the enterprise space, and it's not just a cellular technology that sits with a service provider, and that's where all the applications are coming from. And when it sits a little bit closer and we have this private locally licensed spectrum, that same creativity engine is gonna be there, and we're gonna see a real acceleration of use cases and different visions for that.
Yeah, it's really exciting to see, to bring that to, and that's, I think, what we've heard in the industry about 5G is more low cost deployment. The cap, from what I've understood from the carriers, is that, we put a lot of capital into deploying the infrastructure in previous versions of the network, 60, 80 billion a year. And that number is expected to drop. And it is because of technologies like what you guys are creating. Easier to deploy. Private enterprise has the ability to do their own networks versus private networks, that kind of technology. So that's really exciting. I mean, for a business leader in different industries, what are your target industries that you guys are looking for? All of them, any of them, or anything in particular?
Oh, all of them is always the right answer, isn't it?
Yeah.
No, the
bigger the TAM, the better it is.
Yeah.
Yeah.
I think the service providers, deploying more small cells is a clear, path. And then there's also a lot of work that's going to involve the government and the military is transforming, and moving things to 5G. And we certainly see some opportunities to get involved there. And like I said, there's a number of areas where we're working with people who have the satellite NTN vision, and that's a little longer term, but definitely we'll get there. So that
cool. That's awesome. I can't wait to see what comes next for you guys and sort of see where you start playing a role in a lot of these use cases. So there's always so much going on behind the curtain that we don't see. There's so many companies like EdgeQ that are making things happen that are not out in front in the light that we see on a day-to-day basis. And it's comforting to know that there's innovators like you guys that are, without you, the changes going on so rapidly and exponentially would not happen. So thanks for sharing and teach us a little bit about how it all works together and what EdgeQ is doing.
Oh, appreciate it. Appreciate being on, and appreciate you guys. Like I said, I keep learning every time I listen to your podcast too. So.
All right. Well, till next time, thanks for listening. As always, check us out at 5gguys.com. You can get all our episodes. You can search for them. You can submit ideas for new episodes. You can even put in a request for some help. And Wayne and I have been known to give away some of our time for some free upfront consulting. And sometimes those opportunities can turn into episodes themselves. So thanks again for listening. And until next time, be safe.
Take care. Thanks.
Thanks for listening to the 5G Guys. For more resources and to connect with Dan and Wayne, check out their website at 5gguys.com. If you enjoyed this episode, be sure to hit that follow button and share this episode with your friends and family.